Okay, well, I'll keep going for a few moments.
All right, you're okay. We're on.
I think Ron was certainly the first, following a session that we did on the 2D CAD, and I'm so pleased that he's coming to show us how to put an airfoil section together, amongst other things. I realised what I hadn't done. I hadn't entered the 0 twice, because I should have actually put 0 in on my AutoCAD, but that was a rookie mistake, but caught on the fly there. Can I just remind everybody, please, Q&A, if you can put all of your questions in the Q&A box rather than the chat. Chat is for a little bit of banter and a little bit of general frivolity, really, I would suggest. But the Q&A, and then that means that the three of us can actually sort of look at the questions, respond directly to them, or put them to Ron throughout the talk, and that'll hopefully make it a little smoother for us. Andy, are you?
Yes, I think I'm just going to briefly share the screen. Yeah, I don't know if everybody has signed up to the In the Air Tonight forum that we created a week or two ago now. I know it's up to about 120 people signed on so far. But as I mentioned a little bit earlier, Jonathan Robertson had an excellent idea on the forum. So I'm just going to share the screen now, and we can see what Jonathan put there, and it's based around the plan from AutoZone, so a freely downloadable plan for the Acromaster. And he suggested a bit of a collaboration stroke mass build, something we can all work on together using the forum. I just think it's an excellent idea for people to get involved with. I hope you all think the same. And if so, I would say pop across to the forum, join in. It's perhaps help, with producing STL files and various bits and pieces, and have a real good collaboration. With the possibility, because one of the other ideas I've had, and I was speaking to Manny earlier today about it, is potentially later in the year we all have a bit of a get together in real life, so we can all see if we've got things below the chest, see if we've got legs and can walk around, or trousers, and perhaps meet and do a bit of flying as well. And perhaps an ideal opportunity for that is at the Builders Show that takes place at Buckminster beginning of October. So there's lots of traders there, but there's opportunities for demonstrations and things as well. So, if we've got, maybe see how many Acromasters we can get built by then, and go for it. So
it might be an idea, Andy, maybe to look at it also as being something that could, as an alternative, build in Depron.
Yeah, absolutely. Yeah, well, this is the thing, that there's a big pool of expertise out there. And if we could do this in many different ways, and whatever works, built up wings, foam wings, and so on. So I would ask anybody who's interested, pop across to the forum and have a look at that. We have got one or two other potential ideas that we are sort of batting around at the moment, but that's we need more flesh on the bones of those before we talk about those. So I'm going to stop screen sharing now.
Thank you.
And we will we'll pass it back to Mark and Ron.
Yeah, thank you, Andy. Just a final heads up for next week. We've got the design and building of a 3-axis CNC router with Michael Campbell. So that will be could be really enlightening. That's for anybody who likes to do a little bit of putting together some electronics and kit. Well, I'm looking forward to that one. I think that should be superb. But Ron, I think we've held you back long enough. We're 10 minutes in. So without further ado, I think let's throw it open to you and look forward to the session. Thank you.
Okay, thanks, Mark. Well, thanks, guys. For those of you that, and most of you won't know me, I'm Ron Gray, an avid modeler, have been for many, many years. I'm now just entered my 70th year, and really I've got into this technology side of the sport because I find it incredibly interesting. And In the Air Tonight has been a great thing for me as a tool to be able to listen to what others have to say about technology and how it can be used. And my dabbling, yes, I've been doing 3D printing for about 3 years, but I only just started getting into laser cutting about 4 weeks ago. I bought my first laser cutter, which is a diode cutting machine. So I'm no expert. But what I thought would be good, following on from Mark's presentation a couple of weeks ago using AutoCAD to produce information or sketches or objects for cutting, I thought, well, as I've got a 3D printer, I use Fusion 360. Fusion 360 can produce 2D sketches. They can be taken into my software for laser cutting. So I thought what might be nice tonight was to follow on from Mark's presentation and show an alternative to AutoCAD to do the same that Mark was doing a couple of weeks ago, but using one bit of software, primarily Fusion 360. So that's what I'm going to do. So I'm just going to share my screen. Hopefully you should all see this now. So I've got Fusion 360 loaded. Now, when I first started to use Fusion 360, I had experience of 2D CAD. I used to design extensions for buildings and things like that in my spare time as a sideline hobby stroke business. So when I came to Fusion 360, it slightly threw me. And the reason being that in something like AutoCAD or a 2D CAD, you're like working electronically, but on a sheet of paper, flat on your desk. Fusion 360 or a 3D bit of software, it's different. It doesn't know where you're working. You have to tell it where you're working, which plane you're working in. So when you look at Fusion 360 here in front of me, it doesn't know whether I'm horizontal, vertical, at right angles. In other words, the x-axis, the y-axis, or the z-axis. It doesn't know. So everything you do, you have to start from telling it where you're going to work. Another thing with Fusion 360 is that you can work in various ways. You can work on 3D models, you work in 2D, you can work in surfaces, on sheets, and that's what all this menu, the bits at the top here for the menu mean. But fundamentally, most of them start with having to create a sketch, first of all. So like a 2D sketch. You're starting from, as it were, ground zero. So just to give you an example, I'm going to click on this at the top of my menu here, this sketch icon, and immediately it goes to the screen and it's in effect saying to me, which plane are you going to draw this on? So I'm going to draw it on the horizontal plane here. Now I'm looking down on top of it. So if I wanted to draw a line, there's the line icon. I can just draw a line, specify the next point, and on I go. Delete it. If I wanted to draw a rectangle, there's my rectangle drawn on there. Now you'll notice that when you're working in dimensioning objects like this, there are highlights on, as it were, the handles on the side of the object. This means that I can type in the dimension and it will automatically draw that shape for me for the dimension. But with the dimension showing, I can double click on that and alter it. So once you've drawn something, it's dead easy to alter it as long as you're showing the dimensions. Now that's going to come in handy in a moment when I go over to look at how we can create a wing rib for laser cutting. I said about 2D and then going into 3D. So we can take our 2D object, which we've got now, and actually tell it to build a box from this, a solid lump. How can we do that? Very easily. We can click on it and then use a command called extrude. And we can actually just type the E on the keyboard and that takes us to the extrude command. And there you see it says specify the distance, or you can just grab hold of the arrow, do that. There, I've got a lump on my screen, which is a box there, a solid lump. Okay, now we were talking a few weeks ago about things like servo clips, or not servo clips, sorry, receiver clips, which are, it's got a bottom, it's got sides. Well, why can't we do the same with this? Can we create this with sides? Like most good software, there's more than one way to do it. Fusion 360 excels in providing a multitude of different approaches to do the same or one job. There's no right or wrong way of doing it. Whatever suits you is the right way, as far as I'm concerned. So let's take this object, and what I want to do is I want to, in effect, cut out the middle of it. So I can just highlight the top surface. I can right mouse click and say, right, let's create a drawing on the top surface. Why do I want to create a drawing? Because what I want to tell Fusion 360 is this box, or sorry, this lump, this cube, is actually got sidewalls. So if you recall 2 weeks ago, Mark used a command in AutoCAD called offset. I can do exactly the same here by double clicking. It marks the outline in blue. Put O on the keyboard, -1, and that's bringing my inner line offset from my outer line. You can see it in red. Click OK. Now, if I just zoom in, there you can see there's the outer edge, there's the inner edge. Now, a few moments ago, I used the command extrude. I can do the same thing, but instead of extruding it to make it bigger, I can extrude it downwards and cut it there. I've now cut that, and I've got a box without a lid. Very simple, very easy. Things to remember about Fusion 360 are most of the commands, the simple commands that you use day in, day out, line, rectangle, circle. You don't have to go to the menu bar to access them. They're all on the keyboard. L for line, R for rectangle, C for circle. So you can form these things very quickly. I've already mentioned extrude is an E. But I also said a few minutes ago about there's more than one way of doing things. So let's go back to where I was before I extruded this and before I marked the outline. There's my solid lump. Another way of creating a hollow is to take the whole body, which I've now got there, right mouse click there, and what I can do on that is I can give it a function called shell, which will actually make that hollow. So that's another way of approaching the function that I just did. Just finish my sketch off there. I'm just fighting my way around the various Zoom pop-ups that are on my screen. So, like I say, more than one way to do things in Fusion 360. And these are the things I taught myself. We've mentioned in the past YouTube being a source of all information. It's an incredible source of information, especially I found on Fusion 360. So what I tend to do, if I'm stuck on something, I'll go into Google, I'll just type in Fusion 360 and let's say shell, or Fusion 360 loft, or Fusion 360 sweep. And what happens? YouTube comes up. Here's a worked example of what you do. And usually about half a dozen of them. I've got my own favorites to who I go to look at things, but choose whichever one you want to help you do the work you want it to do. So we just move these images out of the way because I can't see I'm just going to resize this because my Zoom is taking over my window a bit too much and I can't see other tabs. Okay, so the point of tonight's session was using a lot of the basic tools that I've just shown you there to create a rib that I can then take into my laser cutting software and take it right the way through to cutting the ribs out of balsa. So I'm just going to open up a new clean screen. Remember what I said about Fusion 360 needs to know where you're starting. So create a sketch. I'm going to, again, go on the horizontal plane. Now, with my wing rib, the way I do this, and it sounds like I'm an expert, but I'm not. The way I've taught myself to do this is the first thing I'm going to do is to, in effect, dimension the chord. And I'm only going to do a very simple parallel chord wing so the one rib suits the whole wing. If we went into a tapered wing, then the way of producing ribs for cutting is a little bit more complex. And we can't do that tonight, maybe another session later, but certainly not tonight. So this is just the basics. So the first thing I'm going to do is tell the system the chord that I want the wing or the rib to sit on. So I'm going to create my first point, which is here. And then I'm just going to go over here somewhere and draw my second point. Again, referring back to what I said about sketches having dimensions, and that you can type a dimension in which will in effect redraw that for you. I get myself into the habit of always putting dimensions on my drawing. So I've just pressed D on the keyboard and now drag that down, and there's my dimension. I'll just put it as 150. I'll just change it. So I didn't actually draw that as such. I just put in a starting point, an end point, and clicked on the dimension to tell it what length I wanted it to be. Now, because this is going to be a wing rib that includes a leading edge, and it includes spars, and it will include a trailing edge, if I'm going to download from the internet a DAT file of, again, using what Mark did a couple of weeks ago, a Clark Y section wing airfoil, obviously that doesn't know anything about leading edge, trailing edge, position of spars. So the next thing I'm going to do, I'm just going to draw some rough positions for those elements on my screen now. And I'm just going to use the line command. I'm just going to draw a vertical line, L for the next one, L for the next one. Doesn't matter where I draw these, here and there. Next thing I'm going to do is put the dimension command in, because I want to set the dimensions for each of these elements. So I'm going to dimension that from there to there, drag that down. Funny enough, that's what I wanted, 15 mil. But these positions are all going to be from the leading edge. So bring that one down to there. I'll leave that as 75. Leave that as 50. And leave that as 25. Now, I know that on this wing, 150 millimeter cord, I'm only going to have, let's say, a 10 mil leading edge. So I'm just going to double click on that and just change that to 10 mil. I know that, yeah, 50, it's 150 millimeter wingspan. We're going to have our, let's say, our spars at 50 chord. We'll leave that. But our rear spar, I'm going to change that. I'm going to put that, say, at 100, and we'll leave that there. So I've now positioned where my spars will go. The next thing I want to do is to now bring in the airfoil. Now, if I just quickly go onto the internet, see here, I can search. In fact, I'll go onto my bookmarks. There's there. Airfoil tools, airfoil databases. There are lots on the web, but basically this is one which is quite handy here. Gives you loads of different airfoil sections. There's our good old Clark Y airfoil. And what I can do is just say, right, I want that file. So right mouse click, download link file as. I'm going to put it to there. I've already actually got it in there. I'll save it to there, replace it. Okay, so that's now saved that. So let's go back to my Fusion 360. Now, the great thing about Fusion 360 is that because it's an extremely popular program, people make specific little, if you like, mini programs to fit with inside it. They're called plugins. And what a plugin is it's a self-contained bit of programming that works with the overall programming tool of Fusion 360 and can be accessed from within it. So it's been designed, endorsed by Autodesk, the Fusion 360 developers, and you can then use them yourself. Freely available, most of them are. Certainly the one I'm using is freely available. And to bring a file in, a DAP file of an airfoil, all I have to do is go to my sketch, and you see it's already put this little add-on airfoil. If I went to utilities, it's also there as well. So I can go down there. Now, this bit of software is a relatively new bit of software, a couple of years old. It's certainly been kept up to date, and it's incredibly powerful. It's got far too many things in it for what I want, but you can create your own wing profile, create a strut profile, create a cowling, airfoil duct, propeller, turbine, goodness knows what else. You can do all this well above what, you know, my capabilities. I haven't got a clue what it's doing. All I want to do, quite simply for today, is to import the airfoil from a data file. Now, I'll come back to the software in a moment, just in a little while after I've done the wing rib, and just show you all of the different things that you can do building your own airfoil section. But this is the simple approach. So the first thing I want to do is select my file. So there's my DAP file. It says, where's the nose point? So I just click on the nose point. Where's the tail point? Click on the tail point. Now, I know that when the Clarke Y airfoil comes in, it will come in like with a bit of, well, I say it's incidence, it's not, but it looks like it. And I want the underside of the wing to be horizontal. So I know that I've got to change the attack angle to 2 degrees with the Clarke Y section. The next thing I'm going to change is the set of points. You can see here, as soon as I've done that, it shows what this means. The DAP file is, if you like, XY coordinates. They're points all around the airfoil section. And if you choose the default, you will get a load of dots appearing on the airfoil line. And if it's a simple airfoil, in my opinion, you don't need it. So I'm just going to simplify it and say, just bring it in with 30. That's imported now the airfoil section into my drawing, and it's kept it level. There's the underside level horizontal. If I hadn't have told it the 2 degrees, then the nose would be down here, be pointing upwards. Okay, so I just try to keep this simple. But the other reason I want it to be level is because that's how it's going to be built on the building board, and all my spars are going to go in flat level with the building board, not going to be at an angle. So that's why I've changed the import so that I've got rid of that, if you like, that incident, so it comes in flat.
Ron, can I just interrupt you for 2 seconds?
Please do.
One question's just come in just about the add-ins, albeit plugins, you can call them whatever you like. Really.
Yep.
One of the questions is, do they all work with the free version?
Yes.
Cool.
Yes. They all work with the free version of Fusion 360. All that means is that it is the full version, apart from a couple of things, basically. And that's when you're converting STL files back to, so you can work in them. There are some changes they've made on the commercial version. But basically, the free version of Fusion 360 is exactly what you're seeing here. You just have to confirm that it's not for commercial use, and you have to re-register for it annually. I've got the commercial version. I paid for 3 years for it, I think, because I wanted to have that extra function of being able to take an STL file and convert that back to a solid that I can work on in my Fusion 360, but I haven't really used it that much. So when my period of time expires, I'll go back to the free version. But yeah, they'll all work.
Thank you. I'll let you crack on with it.
Yeah,
Thank you.
that's okay. Now, you can see when I click on the profile, you can see all of the, in green, the dots. These are ones that show how the polylines have been created, or the polyline, I should say, the spline has been created around there. If you wanted to change it, you can move those around. Obviously, you're changing it from the standard airfoil. But the thing I'm just going to do is just going to close any gaps there may be in the spline with that right mouse click. Right, now I want to get on to positioning my spars. And now I may look at that one and think, you know what, I don't want it as far back as that. So we'll just click on that and we'll put that to 40 and move that back. The idea of having these dimensions on the screen is this bit of manipulation when you're redrawing stuff and altering stuff becomes very, very easy. Okay, right. The next thing I want to do is to actually put the spars in position. So I'm going to cheat a little bit in a way, and I'm just going to select this vertical position here. And remember, previously when I did the box, I used that offset command, which is create a line in parallel to the one that I've got selected. Press O on the keyboard, put 4. And that's going to tell me where the front and the back position of my 4x4 mil spars that I'm going to put in are going to go in place. Now, the only reason I've done that is it will become clear in a moment why I've done that. It just makes my job a bit easier. So I'm just going to zoom in. Right. Because the next thing I want to do is I want to draw the rectangle that represents where the spar is going to be. Now, if I hadn't put in that secondary line there as an offset, you may not be able to see it, but there's a slight, obviously, downward slope on the profile of the rib. So if I had started from that corner and put a rectangle in, the line would have come down there. So I'd have been left with a notch between the top of my spar and the rib, which I don't want. So this shows me at a glance, I want to start my rectangle from that point and not that point. So I press R on the keyboard, go to that point, and I just need to draw down there and go 4 by 4. That's now positioned that rectangle in there, which is my spar. Now, just to make that clearer for you, we can now trim the bit that we don't want in there because we don't want this top middle bit in there. So T is trim. That's the top of my rectangle, but of course that is still part of the rib. So I cut that, and you can now see that I've got that cut out there. I'm going to do the same with this bottom one here. Go to the R, go to there, 4 by 4. So I'm just typing in 4, tab 4, and that puts my rectangle in place. Again, I can trim there and trim there, and I've got the rectangle formed. So let's just move now to here. Now, I didn't do an offset on this one because it's obvious where I have to draw the rectangle from. So start from that point, go down 4 by 4, enter, and there it is. And again, I'm going to do the trimming exercise. Let's zoom in so you can see exactly what I'm doing. Trim that one, trim that, trim that. Okay. So that's trimmed the various lines around so you can see where the spars are going to go. Quite obviously, when I cut this rib, I don't want that bit cut out for the leading edge or the bit for the trailing edge. I'm going to assume I'm going to put some preformed trailing edge balsa in this wing rather than using ribs. And I'm not worried about an aileron or flaps or anything at all like this. This is keeping it very, very simple. So using the trim command, trim my vertical line, trim round there, that cuts the nose off. And again, trim here. And that cuts that off there. So what I've got now, I've just got these vertical lines that I can get rid of. Just delete those, just highlight them and delete them with the backspace, delete. Nicely cleaned up now. And there's my rib ready for sending to the printer. Now, I know that actually it's not complete. And the reason I know that is because when I'm clicking on these, there's not a joined up line. And that's because there may be at some point where a line hasn't perfectly met with another line. In other words, that doesn't intersect perfectly with that. It's not a problem because we can just go through and we can extend these various points so we get there. And you see, when I did that, all of a sudden, this got shaded in because that's where it was missing. It was only a minuscule amount, but it was enough so that my shape didn't get filled in. Now, there's my rib. So I can finish my sketch there. And on the side, I've now got my sketch. I can now save this as a DXF. But before I do, I'm actually going to go back into that because I've just noticed I forgot to clear that one. So just edit sketch, trim, trim, finish sketch. There we go. Now, this again is something you get used to with Fusion 360 that, oh, I haven't finished it, or I've done something wrong, or I need to go back on something. It's a great tool that you can just jump back a step. And what you'll see when you start to design bodies and huge objects in this, you'll get a timeline that forms at the bottom here. And the timeline allows you to step back 1, 2, 3, 4 steps, jump back 10 steps, alter something, then come back in. So it's not like the undo command. The timeline allows you to jump in, alter something, and that will then affect your end result. Anyway, as time's cracking on, I want to create a DXF from this. And I know this is a query that was raised a couple of weeks ago. Can you create DXFs and sketches in Fusion 360? Well, there's my sketch. I'll just go into there. I'm going to save that as a DXF. I'm going to save that as a rib. I've already got rib 1, so we'll call that rib 2. Save it there. That's my rib saved. Now, I'm going to jump to my laser cutting software, which is Lightburn. And I'm going to open all supported files, rib 2. And there it is. There's my rib ready for cutting. But I want to cut more than one rib because this is a parallel core. I want to, let's say, have half a dozen ribs. So the first thing I'm going to do is I'm going to make sure that when I move this, all the bits come together. And the reason I say that is because if I click on this, it doesn't necessarily mean they're all those pieces are joined up as one set of lines. So I'm just going to group them together. Just going to go to arrange on those and group those. The next thing I'm going to do is rotate that through 90 degrees. The reason I'm going to do that is because if I just scroll down, I'm going to move that down here. And the next thing I'm going to do is say, okay, what am I going to cut this onto? What size is my sheet of balsa? It may be a whole sheet. It may just be half a sheet. I don't know. So I'm now going to draw a rectangle that will represent the sheet of balsa. So I'm going to say it's 100 millimeters wide by, we'll say, 350 long. I've got an offcut. Now in Lightburn, this is now telling my laser cutter what to do. When Barry did his presentation a few weeks ago, he mentioned all of these color things here. These are like, again, they're the properties of cutting lines. In other words, how you're going to cut the line of the object that's on the screen. And right at the end, we've got some that are non-cutting lines. They are frames. So if I click on that, you'll see this has changed color. It means that the laser's not going to go round that and cut that out. But the only reason I've put this on the screen is because I want to, if I set that down there, because I know that's going to be where my cutter will start, I can now take this rib, let's move that to near the edge and say, right, I want to replicate that because I want 6 ribs. So I can go to this pattern or array and tell it, I want 3 columns, 2 rows. There are my 6 ribs. And you'll notice I've put in there no spacing between them. I could do things like mirror the alternate columns. So in other words, this rib could be mirrored so that the straight edges butt against each other. So when the laser cutter goes down, it only makes 1 cut for both ribs, if I wanted to. Click on OK. I can now send that to my laser cutter to cut those ribs out. What I could also do is say, well, I want those cut out, but I want those to be kept in the balsa sheet. I don't want them to be cut out, so I want to keep them in the balsa sheet. So let's just select those 3. I'll change the color to green there. Now you'll notice here, let's just get that frame and put that at the top. We've got now line black and a green line. These are the cutting lines, each of which have got properties. In Lightburn, you can set up libraries of materials. You can see here's my material library. And what this means is for these materials, each material, you can tell it the speed that the laser travels at and the power that the laser will produce to cut for the various materials. So if I look at my pine, let's say 9mm pine cut, I've got there speed 100mm a minute, because this is a diode laser, 20-watt laser. We work in millimeters per minute as opposed to per second because they're not as powerful as CO2. And you notice I've got 100% and I've got 2 passes to cut through that. In fact, that's a bit over the top, to be quite honest. I've cut some 14mm pine yesterday, and I used, I think, 100% power, 2 passes, and that cut through that, no problem at all. But if I go to my balsa now, I've got 2mm, let's use 2mm, and I've got cut, and notice I've got cut with tabs. So for the first line here, I'm going to assign my settings for straightforward cutting, and the green one, which is the second set of ribs, I'm going to cut with tabs and assign. It's the same speed, but you'll see here I've got this selected, tabs bridges. So you know when you get your laser cut kits, you've got tabs between the parts. You have to run your blade through those. That's exactly what this is going to do. It's going to put tabs in so they won't just drop out of the sheet. Click on OK. And now that's it. I could then send that through to my laser once I've lined it up. Now, I'm not going to put another camera on and walk out of my cottage, up my garden and go in my workshop and sit in front of the laser doing this because it's too cold. So in Blue Peter tradition, Here's one I did earlier. Okay, so just make sure the base is lined up and the settings. Set the height of my laser head. I'm wearing my protective goggles, which are these ones. So we're all ready to go. We're just going back into the Lightburn software, making sure it's set correctly. Until it's to firstly frame rather than cut. So that's where I'm going to frame 2 batches of 3 ribs and take that. First 3 cuts. And that's it, finished. So I'll just open the laser and switch it off. So you stick the fan blowing, goggles off so I can see what I'm doing. And that's the cut through there. These ribs are cut right the way through, so I can just pop these ones out quite easily here. Like so. Notice nice clean cut as well, not overburnt. These ones here, I've actually made them stay in the sheet until I apply a little bit more pressure, like I did there. There, you can just see them. There's small tabs here that I've allowed it to create to keep them in the sheet. It's useful if you don't want all the bits to fall out when you take them off the cutting desk, but it's either easy enough to break them off like that, or sorry, like that, or to run the scalpel through as you would do a kit that you buy. So there we have it, some nicely cut ribs, unburnt or relatively unburnt, so I haven't got to sand them down. Ideal for constructing my flame. Okay. Okay, so that's it. That's taking a simple sketch, doing it in Fusion 360, so doing 2-dimensional work in Fusion 360, taking it through to another bit of software, which, like a 3D printer, you have to put your design into the 3D printer slicing software to tell the 3D printer what to do. In a similar way, Lightburn, in my case, I put the design into that, and that will then tell the cutter what to do and how to perform. Very, very straightforward. I've only been doing this 3 or 4 weeks. I've already produced a multitude of things with the laser cutter. I love cutting with it, challenges with it. Depron, it's absolutely brilliant at. The hanky-planky plane that was in November's RCM&E, you may have seen my posts on the forum about that. Brilliant, cuts that superbly. So that really concludes the presentation that I had planned to do. Are there any questions?
Ron, a lot of the questions are going to come through in a few moments. One I've got to ask, because I did answer it by typing. Somebody asked about, have you played with constraints yet?
Yes.
Did you want to just spend 30 seconds or a minute or two just explaining the basis of them, or it's a bit complicated, I realise, and
I would say that won't do it justice, to be quite honest. Things like preferences, constraints are all things that are important, but because they are important, you need to spend a little bit more time on them. One of the things, for instance, preferences, I can set up a drawing and I can name my preferences for it and say, right, length, width, height. I give them names, physical name, actual names. I can assign those to the elements on the drawing and then just go in the preferences and change them. And it changes the drawing. And that's where constraints will come in as well, because if you've got constraints, it's relationships that exist between elements on a drawing. And it means that if you move one, another one will move, or it can't move, as the case may be. So, but the whole thing about constraints, I'm happy to go through that. Like I say, I'm no expert, but I'm happy to go through that, but not in just 2 or 3 minutes. There's not enough time to do it justice, to be quite honest, Mark.
It was a leading question because I've played with constraints myself, and I realise that it is a complex one, but it is, somebody mentioned it, and it does give you the ability, if you do spend some time, to be able to multiply things up very easily, to change things and adapt very, very swiftly rather than redrafting something. And I think that's one of the key elements of it. We'll drop, let's leave that one there. I've got a couple of other questions here. John McNamara, how would you handle ribs for a tapered wing?
Right, that's another session in its own right. So what I do for a tapered wing, he says, sounding like an expert, but I hasten to add I'm not. So what you do is you have a root rib, you have a tip rib, and you join the two together. There are basically two real ways in which you can join them. You can join it using a command called loft, which is you loft something from one plane to another plane, or you can sweep. And again, it's the same thing now. The loft is made for very, if you like, simple, from going from one plane to another plane of a different dimension, but if you like, with straight edges, for want of a, it's not strictly true, but if you've got an elliptical wing, let's take a Spitfire wing, classic one, an elliptical wing, you wouldn't be able to loft that from one to the other, you would sweep it. And the way you sweep it, you would have to draw the lines, the elliptical lines of the outer edge of the wing. And when you move the root rib to the tip rib, you say that the constraints you're going to work within are the lines that you're sweeping along. Okay, they're the rails that you're sweeping along. But in terms of the ribs, now you think about it, mine's dead simple. All the ribs are the same. But on a tapered wing, all of those ribs are different. So again, what you do, you have to think outside the box. There are several ways of doing it. The way that I would do it is when I would create the wing, not as a solid object, but use the loft command or the sweep and create a sheet of the wing. What I would then do is create like a rib plate, rectangular rib plate, that's actually not just a sketch, but it's, you actually, there's a command in Fusion 360 that allows you to, if you like, infill a sketch without giving it any thickness. So you do that, and you then say, pattern that along the length of the wing at the spacings that you want, say 50mm spacings. and that will then put in your 7, 8, 9 ribs, but they're all the same size. You then use the wing sheet to cut out of those vertical panels that I've just created, and that will leave you with the ribs. So that's in a nutshell how you do it. I'm happy to do another presentation based on that, because by Joe, it's really interesting, because you can create your spars as well like that, you know, and tapered spars, everything can be created. It's mind-blowing to start with, but all of a sudden it comes together and you think, wow, that's good, that's fun. And that's the brilliant thing about the software.
I think, yeah, there's a request coming already. Could you do a demonstration on making an elliptical wing, please? That's from Phil Goff.
With washout, no doubt.
Yeah.
Right. George asks, is there a parametric function available? For example, can you change a dimension and the sketch updates to that? We've just covered that, but certainly spars 5x5, for example.
Yeah,
constraints.
I mean, similar to what I did with the positioning of my spars, and I had the dimension, and I said, right, change the dimension, and it changed the position. Again, if I go back to what I said about the preferences, I could have one named spar, 4 mil. And that's what I just type in there. Just instead of typing in the 4 mil by 4 mil, I would just say spar. And that would say spar. Ah, I know it's 4 mil. If I then wanted to change it, I would just go back to my preferences and change spar to 5 mil. And it would change the spar to 5 mil.
Brilliant. Thank you for that one. Keith Barker, how do you work out the speed to cut so you do not get a very burnt edge? So we're on the laser now.
It's called test. Right. So in Lightburn, I'll just, where are we? I'll just go back to he says lost where am I? Would help if I got Zoom up. Let me just quickly share my screen. Again, in Lightburn, has got built into it. You can't, well, you might be, it's right at the top of my screen there. Laser tools, material test generator. So what this will do is it will create boxes or squares, and you can tell it this is 10 by 10. This would create a 10 by 10 test of running from a minimum speed of 600 millimeters a minute to 1800 power 10 to 100% squares. If I preview that, that's what it will do. So the laser, if I just play that, that's what the laser will do. It will zap all those, and you can see that 10% right the way from 600 millimeters a minute to 18,000 millimeters. Obviously, I wouldn't do that. I haven't changed it, but and what I do is whenever I come to a new bit of material, like down here, not necessarily when I was cutting my EVA foam, here we go, EVA foam, 20 mil. I hadn't got a clue what to cut that at or to engrave it. I hadn't got a clue. I couldn't find anything. So I just set up some test cuts on a piece of foam, and I was very lucky that I was there or thereabouts with my guess. So it was either side of that. But you're quite right. What I hate is when I cut something and it's got a burnt edge. Those ribs you saw, clean as a whistle. As a whistle. So I don't advocate going to 100% power and going fast. On Depron, I set mine up the other day just as a tryout. I set it at 6,000 millimeters a minute at a power of, I think, 60 or 70%, and it's going too fast. The problem with Depron, I've got an 800 by 600 sheet of Depron, which I'm laying on my cutting deck. The Depron is slightly bent, slightly curved. I've got to keep it down. If I'm putting weights to hold that down, and I've got a laser head shooting up and down the sheet of Depron, I can't keep up with it and move it in time. So I slow it down, half that speed, 3, instead of 6,000, it's 3,000, roughly the speed that the ribs cut at. So trial and error, spare scraps, and create your library of materials there.
Brilliant.
That's what you do. You create your library of materials. My daughter makes flowers, so she wanted me to laser cut felt. Each one of those has got a different setting because they're different colors. And the problem with the diode laser is it's no good on white or clear material because it's a blue laser, as you can see from the video, and it will be reflected. Unlike a CO2, which is more of in the sort of infrared range, and that will cut through white and clear. So on the lighter colored, like whites and everything, I have to play around with the power, and she didn't want it burnt. So I spent ages cutting. You can see all the different colors there, all the way down there. Each
Patience of a saint, I think.
But you only have to do it once.
Yeah.
That's the beauty of it. Next time I got to cut some of her copper colored, I just choose that setting, and that's what I use.
No, that's absolutely it, Ron. And I can advocate it's the same, and Barry will tell you the same. We all test and test and test.
Yeah,
I can tell you when I'm cutting indoor balsa for some down to 15 or 20 thou thickness, the different density of balsa requires a different setting, and some people just do not believe that. But I can tell you, the difference between a 4 pound piece of balsa wood and a 6 pound piece of, 6 pound per cubic foot density is phenomenal difference in the laser cutting.
Well, I came across in my stash of balsa because I was I wanted to cut some doublers for some hanky plankies. I came across some, it must be 30-year-old balsa. It was brown. Eighth of an inch thick, brown. And cutting that, I've got no other balsa like it. Even my hard balsa is not like that. It was like mahogany. So the cutting was completely different to the newer stuff. Completely different.
Yeah. So balsa, the lesson for balsa wood that I would give to everybody in general, that you may have to overcut balsa wood, because if you're not careful, you could be playing around with every single sheet, and it is a little bit like that. 1/16 balsa wood. Get something that cuts through and accept it. You can play around, but you can't pick up the same piece of sheet twice. It's
very true.
A couple more questions, and then we'll start to draw this to a close. Robert Harris, how expensive is your laser cutter? You may not wish to answer that one, but
no, it's fine. My laser cutter is a Sculpt Fun S30 Pro Max 20 watt. So in terms of diode laser cutters, it's quite powerful, although having said that, they're now coming out literally in the last month 40 watt, but mine's 20 watts, and I got a larger, because I wanted a larger plan base. So mine measures 900 by 400, actual can cut 800 by about 380. That cost me delivered £750.
Wow, it's brilliant. No, it's brilliant. Second part of his question, do you know if you could export your DXF files to a cutting service? I think we all, there are plenty of cutting surfaces. I wanted you to answer, but we're all nodding there. There are a number of them. I think they used to be we used to have it in the BMFA news. I think in the back there was a cutting service advertised.
There are lots around. I mean, I know Sleck, for one, just up the road from me at Watton, they will do it. I don't know if Sarek will do it. Sailplanes, they'll do it. So yeah, it's a DXS file. It's a data exchange file, common file. Just give it to anybody who's got. Find somebody who's got a laser cutter, like someone like me or local to you, and they're more than happy to do it.
Brilliant. Last question, then I want to just run through a couple of the chat points from Eric here. As the laser does not like white, how did you cut Depron?
It's grey. Grey Depron. And also white Depron is like rocking horse poo. They've really stopped making it. So right. It is grey, and grey cuts beautifully.
Absolutely. Look, Ron, I just say fantastic presentation. You've done us all proud. I just wanted to sort of just nip through a few of the comments here. I had to go sort of about 40 comments through to go simply amazing, absolutely brilliant, superb, John, superb job, Ron. Put my teeth back in. Thank you, Ron. Very interesting, great presentation. Layman's terms, brilliant, and it goes on, and we'd be here for the next hour. So, you know, you've excelled, sir, and it's wonderful.
Thank
Your
you.
offer of coming back is without question. We will get you back. I think, you know, there's so many people actually, you know, answered so many questions. I mean, Jess answered so many questions. I think this is what it's all about.
Yeah. Well, it's all the other thing, Mark, about it is, you know, I've taught myself, I've learned from my mistakes. And one of the things that I've seen on the forum on here is people being, as it were, afraid of this. There's nothing to be afraid of. Just get in there and use it. It is logical. It is straightforward. And above all else, it's good fun. It really is good fun.
Yeah.
I'll give you an example. A colleague of mine yesterday, I've just bought an FMS Viper jet, and the undercarriage is not very good, so I'm replacing the undercarriage, but that means I need smaller diameter wheels. So I laser cut the tires down on mine. And as a joke, he said, and he's on the call tonight, he said, "Oh yeah, but it hasn't got the Dunlop, the Goodyear logo on." It has now. I laser cut, and I mean that's 3 millimeter high letters around the circle of the wheel, and that's, you know, that's the fun thing about it, just being able to do silly little things like that.
Absolutely. I've got a piece of a timing device here that I was playing around with at the weekend, and rather than putting it on the laser cutter to cut it out, I 3D printed it nice and thin to trial it out and just test it or make sure the holes were in the right locations. And I can prototype that, made 2 or 3 different adjustments, and then I know I can go onto the expensive material to cut it out later.
Yeah,
so
that's
the
thing.
This is what it's all about. But understanding the basic skills. I love this comment here from Ted Griffiths. Absolutely fantastic, Ron. Blue Peter has nothing on you. So, you know, plenty you've thrown in weapons grade balsa. We've all got plenty of that. Yeah, we often use it for fencing, I think, in the trade. Yeah, just fantastic comments. Barry, have you got anything to add, sir?
Yeah, there was an interesting comment from Michael Kitchen. He says the way forward for actually making model aircraft for the youngsters, all I can say is watch this space.
Yeah. No,
I have to say, as somebody who's not done any of that, that was very clear. It was excellent.
Yeah.
If I had the time, the space, and the money, I'd rush out and buy a laser cutter and everything. But as I haven't, I won't.
I was going to offer, you could always, when you get there, Andy, you send me the DXF files, I'll print it for you, happily do that. But I've got to be careful, otherwise people might start sending me stuff. So please don't.
I think I might have to wait till retirement, which is a good 20 years away.
Divorce would be there much quicker if I started getting too much coming through the post. But no, look, Ron, absolutely brilliant again. Thank you very much. We will have you back, of course. And you know, keep in touch, obviously, on the forum as well. I think it's starting to grow. Everybody, try your Fusion 360. As I said to you, it is a great piece of software. It's very intuitive. I know there are some pitfalls. I think exporting DXF is difficult, or it's maybe not available, but there are other tools that are out there that will actually achieve that for you. So I think it's on the free version. There are some export problems with it, but
With what, Fusion 360?
yes.
Well, I just did the DXF.
On the free version.
No, you can do it on the free version.
You
definitely.
can you?
Yeah. I answered that. Someone asked that question, and I can read you out what the answer is, because I quickly got onto my race buddy, and he said you right click in the menu browser. Let me just get that. Where did he?
Right click on the sketch.
Yeah, right click on the sketch. We did put the answer in. You can definitely DXF out of the free version.
No, I saw somebody had mentioned that, and I've never tried that because I've never used it. I've never gone DXF out of.
Yeah, so you right click the sketch in the browser menu and select save as DXF, and he's streaming DXF files over to me all the time.
Yeah, most people make the mistake of thinking you have to go file export.
Yeah.
Don't. You're actually going straight from the sketch.
It's
Yeah.
a sketch
do-
rather than the 3D
Yeah,
model.
Yeah,
Yeah.
in the same way that I send my mesh files directly from it without exporting, I go straight to my Prusa printer without exporting, because it just saves so much time.
Fantastic. Well, I think one of the things that if Andy's session comes off in October, if we can get that organised, let's see if we can get a couple of machines down there. I've got a couple of machines we can bring down, and we might be able to get some sessions going. And yeah, could be quite fun.
Yeah, brilliant. Really
Brilliant.
appreciate it, Rob. Done a great job. Thank
Yeah.
you.
Thank you.
Thank you very much again, and we look forward to seeing everybody next week for how to build your own CNC machine. So there we go. Should be
And-
fun.
Any further questions, get over on the forum and
Indeed. Yeah, get on there,
between-
continue the chat. That's what it's
Yeah,
there for.
yeah. we've got some momentum going there.
Yeah, I think we should say good night to those on YouTube. Thank you for joining us.